Hello, chemistry students. Welcome to Chapter 11, Describing Chemical Reactions. So we're going to learn how to classify chemical reactions and also even to predict when you react a couple of substances, what the products will be produced from that reaction. So just a quick recap, and I know we talked about this a few times throughout this course, but as we way back in the beginning, we talked about kind of that evidence that we see of chemical reactions, and these are kind of the things we talked about. Some fizzing or bubbling would indicate that a gas is being produced. Two clear liquids mixed together would indicate that a precipitate, if it turned cloudy or cloudy and colored or cloudy and white, would indicate that some precipitate had formed, those little solid particles in there. Temperature change, either a temperature increase or a temperature decrease, it could be either, would indicate a chemical reaction. Change in appearance, like color, also typically would indicate chemical reaction. If you mix two, like I said, two clear or colors or two clear solutions together and they produce something that was colored, that would indicate probably that there was a chemical change. And sometimes light. So some chemical reactions can actually produce light, although that's a lot less common. But what we are going to work through in this chapter is how to balance chemical equations. So in beginning, so we just quick kind of the anatomy of chemical equations. If we have everything on this side of this reactant arrow that we see right here, right? This is our reactant arrow. Everything to the left of that arrow are considered the products. And sometimes there's only one product. Sometimes there's two, sometimes there's three, sometimes there's more than that. It depends what type of reaction it is. So these are the reactants. And then this side would always be the products, what's produced. And again, sometimes that's one thing. Sometimes it's two or three or four, or perhaps even more than that. But reactants and products, so what we're starting with, what we're ending up with. The law of conservation of mass and matter states that matter must be conserved. That means matter is conserved from this reactant side to the product side. And so in this particular equation, I can draw an imaginary line. I'm just going to draw an imaginary line. Let's say, and on one side of my little line, I'm going to list all the reactants. On the other side, I'm going to list all the products. And I'm actually going to separate it by the atoms contained in each. So we can see that on both sides of this reaction, I have hydrogen on this side and I have oxygen on this side. I have hydrogen and oxygen bound together in a chemical reaction on this side. So the law of conservation of mass and matter says if I have two hydrogen atoms on this side, I have to have two hydrogen atoms on this side, which I do. And the same with the oxygen. I have two oxygen atoms on this side. But hold the phone, I only have one oxygen atom on this side. So what happened? This law says that I have to have the same number of atoms of each type of element on both sides because matter has to be conserved. It can be rearranged and we can have different, orders of atoms, but we have to have the same number. So I'm going to pick a different color here. To get two oxygen atoms, the only thing I can do is put a 2 in front of this, and now I do have two oxygen atoms. So we use the distributive property here. So this 2 means I have two oxygen, and 2 times 2, or 4 hydrogen. So by fixing my problem of not having enough oxygen on this side, I've created a problem, but now I don't have enough hydrogen on this side because I need 4. Well, this is pretty easily remedied by putting a 2 in front of this hydrogen. So now I have 2 times H2, or 2 times 2, which is 4. So in this chemical reaction, it is now balanced. So what this means is it will take 2 diatomic hydrogens, 2 of these H2, to react completely with 1 of the O2 to produce 2 water molecules. And that's in a balanced state. See, it's conserved. I have the same number of atoms on both sides. So the process I went through is listing what I have to start off with, and I think that's the best way to tackle this. I can only balance using coefficients in front of. So the thing I could not have done here was say, well, I'm just going to put a 2 here to make that balance. What that says is hydrogen and oxygen react to produce hydrogen peroxide, which is not what we were going for. We were trying to figure out how water was produced. So never, ever, ever change those subscripts. You can only balance by putting coefficients in front of. Okay, let's do something a little bit more complicated. All right, so let's look at this. Again, I'm going to draw this imaginary line. You don't have to draw the line. I'm just doing this so it's less confusing. I have aluminum, and I have oxygen, and on this side I have aluminum and oxygen. Here's my other little tip. Always write these in the same order on both sides of this line. Otherwise it starts to get real confusing. Sometimes I'm easily confused, so I like to make things as simple. It's really easy to look right across from each other. This is 2. Oxygen, I have 3. I apologize, I'm writing with my mouse because I want to keep working on my actual computer screen here. So aluminum I have 1, oxygen I have 2. This side of aluminum I have 2. This oxygen I have 3. So if I look at this really quickly, the first thing that seems really easily to fix would be to put a 2 in front of this aluminum. And I can do that, or I can wait. I don't care if you balance that first or not. The thing I do notice right away is this aluminum is single and by itself, so I can put any coefficient I need to in front of this. So I kind of like to wait until last for that. So as you can see, kind of the difficult one here is the oxygen. I have 3 and I have 2. So remember, if I put a coefficient in front, I cannot put a coefficient here, right? Don't do that. That's not okay. This is all one molecule, and you can only put coefficients in front of molecules. So I have a dilemma here because there's nothing I can put in front of this or this that's going to make the other side balance. But what I can go for is 3 times 2, which is 6. So I can put a 3 in front of my O2. I'm going to erase this, which gives me 6 oxygen on this side. And then if I put a 2 in front of this entire molecule, now I'm going to have 6 oxygen on this side. But it does change my aluminum, which I know is not going to be a problem because I have single aluminum over here. So 2 times 2, which I'm just going to cross that out, which is 4. So how am I going to balance? Whoopsie, you know what, this looks confusing when I put it this way, so I'm actually going to write the 6 for oxygen over here. I don't know why I did that. It's Monday, people. So yeah, now I can just simply put a 4 in front of this aluminum. That gives me 4 aluminum, and it's balanced. And I like to go through and say, okay, 4 aluminum on this side, 3 times 2 or 6 oxygen, 2 times 2, 4 aluminum, and 2 times 3, which is 6. 6. I said sixth. I made a new word. So yeah, that's balanced. Perfect. Let's do the next one. All right, I'm going to write this one on the board because it's just too many to try to write with a mouse. All right, so first of all, you'll notice that, so I wrote all 4 of the elements that are on either side. I just kind of went in order, so Ag, N, O, whoops, oxygen, and then my copper. And then on this side, I just made sure that I went right. I want to go in the same order. So silver, nitrogen, oxygen, copper. So I'm just going to start filling these in. 1, 1, 3, 1. All right. So how am I going to balance this? Well, I noticed right away that my nitrogens are not balanced. I have 2 on this side, only 1 on this side. So I'm just going to pick a place to start. Here's my nitrogen on this side. I'm going to have to put a 2 in here, which affects a whole lot of other things. So it affects the silver, it affects the nitrogen, and it affects the oxygen. So now I have 2 times 3, which is 6. All right, so things are looking better. I have 6 of each of these, 1 of each of these, 2 of each of these, 2 of this, but I only have 1 silver on this side. Super easy fix because silver is by itself. And voila, completely balanced. And there you go. So pretty short, simple, sweet. I know you guys did this in 9th grade physical science. You're probably a little out of practice. Maybe I'm showing you a little bit different way. I'm not really sure. But this is the way that we should be solving these. I'm going to have you go ahead and complete that first worksheet from the HyperDoc. And then please let me know if you have any questions. Good luck.